So when you are asked to multiply radicals, what we're going to use is the product rule for radicals. So here's what it looks like. If I have the nth root of A times the nth root of B, if the indexes are the same, then I can put those, the A times the B, under the same radical with the same index. So with numbers, if I have the cubed root of 6 times the cubed root of 15, that is equal to the cubed root of 90. Okay. So, right, that will let you multiply radical factors together, like we just did. But it also means we can use it to simplify radicals by removing any perfect square or cube, whatever index it might be, and we remove those from the radical. So here's, let me show you how that works. So the first one here is the square root of 24. So what you want to do is think about all of the factors of 24. So all of the numbers that go into 24, and you want to find one that's a perfect square. So maybe you might have a list of perfect squares, right, to get you started. So these are just perfect squares. So 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, dot, 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 right? So perfect square. So you're looking for one of these numbers because it's a square root, needs to be a perfect square, one of these numbers that goes into 24, right? So you choose 4. Okay, so here's what we're going to do. We're going to take that 24 and write it as the square root of 4, the perfect square part, times the square root of 6. That's times the other part. So then the square root of 4, we can simplify that part. That's a 2. Square root of 6 multiplies along. Okay. What about the cubed root of 24, right? So for this one, I'm going to break it apart into the product of two different cubes. But I don't want to choose 4 again because 4 is not a perfect cube. I need something that's a perfect cube that also goes into 24. So let's think about what your perfect cubes might be. So 1 cubed is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed is, right, 27. 4 cubed is 64. 5 cubed is 125, okay, dot, dot, dot. So what one of these numbers might go into 24? Right? Yep, 8. So we choose 8, but now we have to pick, right, for the other radical, we need to pick the partner factor for 8. So 8 times what to get back to 24? That's a 3. So the cubed root of 8 is 2, and then the cubed root of 3 is multiplying that. Okay, so we've taken out that perfect cube factor and left behind the rest, the other factor. Okay, finally, square root 27 x cubed y to the 10th. Okay, I'm going to write this down here because it might be long. So we're just going to go factor by factor. We'll put the perfect square factor in the left radical and then its partner factor in the right. So square root of 27, square root, I'm looking for a perfect square that goes into 27. Right, so here's my list of perfect squares. Which one of these goes into 27? 9. 9 is going to go into the perfect square radical. So 9 times what to get back? Okay, so 3 goes over here in the kind of the leftovers. Now x cubed. What factor of x cubed is going to go into the perfect square bin? I don't want to put it all because, right, the rule about the index and the powers, right, if the index goes into it evenly, it's perfect. It can come out. So what I'm going to do for that x cubed, I'm going to write that as x squared times x to the first, because x squared, right, is a perfect square. I'm going to put it in the perfect square bin, and then its partner, so that I could get back to x cubed if I had to, goes over here in the leftover bin. Okay, last factor, y to the 10th. So 2 goes into 10 evenly, so that comes over here. The whole thing goes in the perfect square bin. Okay, so I've gone through the entire radicand. So now we simplify the perfect square bin. So square root of 9 is 3, square root of x squared is x, square root of y to the 10th is y to the 5th. And then we're just multiplying that by the square root of 3x. Okay, so sometimes what's going to happen is we're going to be asked to, multiply first and then simplify. So here we go. The square root of 18 times the square root of 6. So let's multiply those together. So 6 times 18 is 108. And now I need a perfect square that goes into 108. Gee, I don't know. 9? I guess 9 goes into that. Okay, so then that'll be the square root of 9 times the square root of, I'll do the division over here, 12. Awesome. And the square root of 9 is 3 times the square root of 12. Okay, well that was good, and we simplified a little bit, but guess what? It simplifies just a little bit more because I know that 12 also has a perfect square factor. Right? So look up at your perfect square list and see what goes into 12. Exactly, 4. So now I'm going to leave the 3, and the 12 I'm going to write as the square root of 4 times the square root of 3. Right? Keep my 3 tagging along. Square root of 4 is 2. Now I'm putting my dots in for multiply just to emphasize. Square root of 3 tags along. 3 times 2 is 6 times the square root of 3. How about this one? 4th root of 32 times the 4th root of 64. What are we going to get? 4th root of, gosh, I don't think I want to actually multiply that out because that's just going to be big. So maybe what I'm going to do is I'm just going to write those powers of 2. Right, so 32 is 2 to the 5th. So 1, 2, 3, 4, 5. And 64, what is that? 2, that's another 2, so 2 to the 6th. 1, 2, 3, 4, 5, 6. So I need groups of 4 to come out. So let's see, there's 1, 2. 2 groups of 4. So those are my perfect fourths, right? So I'm going to get 2 times 2 coming out for these 2 groups. And then left over are these 3 2s. So that would be an 8. So altogether, that would be 4 times the 4th root of 8. Okay, square root of 8 cubed times square root of 2x to the 5th. So square root of 16x to the 8th. So the square root of 16 is 4. Square root of x to the 8th is x to the 4th. So I can go factor by factor, right? Because everybody inside there is multiplying together. Okay, last one. Cubed root of, so let's see, 6 times 8 is 48. X to the 4th times x to the 7th is x to the 11th. Multiply like bases, add the exponents. Cubed root. So let's look at the 48. I need a perfect cube that goes into 48. So the good thing about cubed roots is it's going to have to be one of those small numbers otherwise, or a power of 10, right? Otherwise, we just get too big too fast. So cubed root, so we'll do our perfect cube bin and our leftover bin. So it looks like 8 goes into 48, and 6 would be its partner. And then for x to the 11th, so 3 does not go evenly into 11. So what we're going to do is we're just going to go down by integers until we get to a number that 3 goes into. Okay, so that would be 9, right? So here's what's happening. I'm going to take that x to the 11th and think of that as x to the 9th times, what would its partner have to be? right? X to the second, multiply bases, add their exponents. X to the ninth is the perfect cube because the index goes into the power. X squared ends up in the leftover bin. Go ahead and do the cubed roots that you know. So simplify the first one. So 2x cubed, and then the leftover bin just gets written. Cubed root of 6x squared.